So last time we've cleaned up the hospitalizations, and in this part we're going to talk about to identify the patients who are diagnosed of cancer. And we're going to have the date of the first diagnosis of cancer. So that also explains the purpose why we have to do this clean hospitalization, because I imagine that if the hospitalization is messy, like in this case, and if there is a cancer diagnosis here, then it's hard to say that whether this diagnosis was made, so the patient is going to be considered having cancer starting from this date or this date, right? Or this date, because these are all overlapping. So now because the admission and hospitalization dates are aligned, so if the rule is that we're going to use the admission date as the date of diagnosis, then no matter it appears here or here or here, we have the same admission date. So now that part of the job has been done, and now we're going to move into this diagnosis part. All right, so the first step, as I said before, is that I'm going to clean up all the links that I used, the links from the previous run. So the first thing is, of course, we're going to go back and we're going to have a look at the data sets again. Okay, so we've seen this part in the last video, and eventually we have this revised admission and discharge date. Do we still have the original admission and discharge dates? Yes, we do have. So why we have to keep that? It sounds like it's quite confusing, right? Because it's a good habit to keep those original records, because who knows that at some point you want to go back to the original data, you will still have it, right? Okay, so have the diagnosis of cancer, it basically means like this. So let's just simplify that. Let's say these are the hospitalization records. This is for patient 1, 2, 3. And we know that in the hospital records, we have 25 fields to record those diagnosis codes, right? Diagnostic codes. Well, let's just simplify that to the third one, because the rest of that are the same. And let's say that for patient 1, there is one diagnosis of cancer at the third field. That's the third DX code field. And for the third patient, the first diagnostic code field. For the second patient, none of that are related to cancer, right? So we want to, for each of the patients, we want to pick up these cancer-related codes. So of course, we're going to check each field one by one, right? So now we have to understand the two very important concepts about this looping or iteration in SAS data steps. So in SAS data step, usually when we have a data and set and stuff, basically it is going to do the loop like this. So it is going to go for each row of the records, right? So when we say data steps and set and whatever, so it is going to go row by row to read the records. So this is the normal way. And for this one, you don't have to specify that you need a loop or an iteration. However, so if you want for the same row, so before moving to the second row, you want to loop by each column, like in this case. This time you need to specify that you need a loop, which is called for example, a do loop. So basically this do loop means to iterate within the same row, but in different columns. And that's exactly what we want to have here, because we want to iterate for the 3 or the 25 columns. And each time we're going to check if that code is related to cancer diagnosis or not. And if so, we're going to do something. If it's not, we're going to carry on. Right? So that is the concept we're going to do for this do loop, or the loop for different columns within the same row. So that's what we're going to do here. So we're going to have the data set, and for doing the loop, we are going to have an array, and this array is going to have 25 elements, each for a column of the diagnostic code. So it's just that imagine that you can have you're going to have a temporary something, in the memory, the computer memory, and that thing is going to have 25 elements, and each for a record, each for a value in this 25 columns, right? So to be simplified, it is like so we're going to have a temporary uh, let's call it in well it's an array. It's something, something in the memory. We're going to have a temporary thing to remember the values in these columns, but for the same row. All right, so for that array element 1, we're going to have this code. Array 2, we're going to have this code, and so on and so forth. Right. So once we have that temporary array, so basically for the same row, the current row, we're going to have all the codes remembered in that temporary array, which is called the dx 1 to 25, right? And then we're going to do the loop, which is to do it between 1 and 25. And basically, that's how we achieve uh, to read the columns one by one, but stay in the same row and get the values of that. That's what we just talked about. All right. So, and then we're going to do a bunch of checking and do something. So basically, the check is that. This is also quite neat. So what it does is that, okay, I'm going to take the first third strings, the first 3 characters from this temporary, this temporary. So in this value, I'm not going to take all of this string. I'm only going to read the first 3 character of the string, which would be in this case would be this D00. In this case will be F00. This one will be C05. So we're going to take the first 3 characters from the diagnostic code, and then we're going to compare and we're going to check if it is within this range. So you can see that actually, not only for the numbers, but also for these characters, as long as the values are following some rules, like in this case, we know that between the code C00 and C49, which means that, well, if we have a code of C20, C21, C43, they are all within this range, and we can use this operators as if they are numbers to check if this selected code is within this range or not, right? So this is quite handy, right? So imagine that you have a long list, especially like for those cancer diagnoses, you have a long list. You don't have to check that one by one. You just have to check if it is within this range. And the way to check that is nothing different than checking the range of a number range. So it's the same thing here. So the other thing is that you might notice that for this specific element within that array, like this is from 1 to 25. So to have the specific element, whether it is the first one, the second one, you can use the brackets. You can use the square brackets. You can also use this. This is called curly brackets or curved brackets, whatever. So you can use any of that. That all works, right? So basically, that is the way to check that. In this line, basically it means that we're going to check if the code is within this range, but not this one. All right. So if that is the case, then this is a cancer diagnosis, and we are going to record it down to say that, okay, we found a cancer diagnosis, and that diagnosis ID, ICD code is this. We're going to put it in this DX field, and then we're going to remember which column we have. So this is which column we have. For example, in this case, for the first patient, we found it in the third array element of the array. So it is in the third diagnosis. We're going to put that P as 3. For this one, it will be 1, right? Because it's from the first position. And this is important sometimes because sometimes we're going to specify that, well, for this disease diagnosis, it has to be the first position or the first record. So if we want to make a case, it has to come from the DX code 1 column. If it appears in the DX code 2 or DX code 25, it doesn't count. Sometimes the diagnosis like that. That's why we're gonna remember this. Okay, and then if we find any of the cancer-related code, then we're gonna do the following two things. The first is that we're gonna say output it. So when we say output it, it means two things. So the first is that for this record, because I found a cancer-related code and I said output. So the first means that I need this record. I'm gonna output this record. All right. And the second, it means that, well, if I didn't say for another role, if I didn't say output, then don't output. All right, so these two things comes together with that output statement. So basically it says that when I tell you to output the current line. If I don't tell you to output it, don't output it. So this is against the normal way of running the data steps, because the normal way, if you don't have any output statements there, then all the records, all the rows will be output to the target data set. All right. But if you have the output statement somewhere, then only those rows that you specify to output will be put into the target data set. Otherwise, it will be discarded. Okay, so that's what this output is going to do. The other thing is that leave. So what does leave means? So remember that we're still in this iteration, which is for the current row, we are gonna do a loop for each of the columns between 1 and 25, right? And then look at this. So for the first row, for example, by the time we check the third element in the array or the third column, we already find a cancer record. And then in that case, we're going to say that's good enough because we already find a cancer related ICD code. We don't have, for this same row, we don't have to proceed and check the rest of the columns. That's totally a waste of time, right? So in that case, we're going to say leave, which means that you should leave. You can now output output this record and leave the current row and move to the next row and start the loop again. So that's how this leaf is going to work. All right, so putting all this together, so this data step, this block of codes is going to do the following. It is going to check each of the rows and then loop by each column. And if it found, if one of the cancer-related diagnostic code is found, then it is going to keep this record and leave the current row and then move to the next one and do the same thing again until the end of the data set. All right. Now as the result, we're going to have a bunch of hospitalization records. Each is going to have at least one cancer-related diagnosis or diagnostic code. And finally, in this case, because we only want to know whether or not there is a cancer diagnosis, we don't have any particular interest in the diagnostic code per se, and also we are not interested in the position. So at the end, we're only gonna keep two columns. One is the key HSN, the other is the adjusted admission date, because we're going to set this admission date as the date of diagnosis. All right. So I just put this here, the DX code, the position of that, in case that in the future you're going to use that for other purposes, in which it matters that which position the diagnosis is come from. And in some cases, but you might have a particular interest to know which code, diagnostic code, that has been used to make the case. So anyway, in this case, we're only going to have two columns, which is the key HSN and the admission date. Okay, so these are the final data set looks like. But the data is quite messy, so we cannot see clearly here. But I can assure you that actually for the same patients, there are repeated records here. So if imagine that there are two hospitalizations for the same patient, and these two hospitalizations are all going to have a cancer diagnosis, then the patient is going to have two records, right? So the next step is that we're going to sort that, and then we're going to have the first record of each patient, which is going to have the earliest admission date, right? And that will be the earliest cancer diagnosis date, right? That's what the program is going to do here. And then eventually we only need to keep the key HSN and we're going to rename this admission date as the cancer diagnosis date. And we are only going to keep these two columns, which is the key HSN and the cancer diagnosis date. But here, be very, very careful, because if you want to keep this renamed column or variable, you have to keep the name. You have to use the original name to keep it. So it won't work if you want to use the new name, because the keep is going to work for the original name. So that's why I put it here. Anyways, so by sorting and doing this, we're going to have for each patient, the earliest diagnosis, the date of cancer diagnosis. So now what? Now we have all the cancer diagnosis, right? And we know the date of diagnosis, right? And now we're going to link it back to each hospitalization record. So why is that? Because we want, for each of the hospitalization, we want to indicate whether or not that patient has been diagnosed of cancer. So this part of the program, it sounds like it's very long, but actually, the things to do is very simple. So it is going to use the proxy. It is going to link the original hospitalizations and uh, the the cancer diagnosis data, and it is going to link by patient. And for each of the record, it's going to check whether this cancer diagnosis is within the departure and the admission date. So if so, we're going to say that this hospitalization is with a cancer diagnosis. Otherwise, it is not. So basically, it's going to do that. And this long part is long only because the conditions are long, because the expression is long. And because there are many brackets here, so it's better to put it in that way so that it's easier to view it and you're not going to miss any of the brackets, right? So in SAS, it doesn't matter, you put it in multiple lines, right? So the first part of that is just to have a dichotomous indicator, whether it is 1 or 0. Basically, it says, uh, is that a so was there a cancer diagnosis or not, right? So the second part is for the date, so the date of cancer diagnosis. So actually, we're going to attach the cancer diagnosis from that cancer data table and put that into the hospitalization, all right? So now you can imagine that in the hospitalization records, in all of these hospitalization records, right? So the first is that all of these hospitalization records are aligned with the same, as long as they're overlapping, they're going to have the same admission and discharge date. And then you're going to have, for these overlapping records, you're going to have the same cancer diagnosed date there, all right? So, and it's going to, in this case, it's going to repeat for 3 times. Each time, they're going to have the same revised admission and discharge date. It's going to have the date of cancer diagnosis, given that the cancer diagnosis is within this period. Okay? All right, and now for this record, let's suppose that there is no cancer-related diagnosis within this period. Then it is going to have none of the cancer diagnosis there. And then we're going to indicate that, well, so for this record, there is no cancer diagnosis. Now, there are two problems. The first is that these three records now, it's kind of that we don't need these three records anymore, because now we have the cancer diagnosis and the rest of the diagnosis, we're not going to use that, at least not in this project, right? So now, because we already identified the cancer diagnosis, we don't need the three records. We only need one, because all these three records are going to tell the same information, right? So we only need to keep one, which is a distinct one from the three records. And it's the same for these two. So now it is good, it is fine that we only keep the distinct records here, because the rest of the diagnosis information, we're not going to use that, right? Okay, so this is what we are going to do, what we are going to do in the next step, which is to select the distinct records of the patient ID, the admission date, which is the revised one, and the departure date, discharge date, and the the date of cancer diagnosis. Yeah, so that's what we're going to have there. But also notice that here we changed this the date format from the datetime 20 to date part. And now as a result, we are only going to see the date because actually those time part, those hours, minutes, seconds are not so important for us. And so uh, the timing by day itself is good enough. So we're going to only keep the date part. Okay, now we have the final data set for this part. We have all the hospitalization records, and this time none of the hospitalizations are going to be overlapping. So it is always mutually exclusive, and also we have this indication of cancer or not, right? So we add another order number to indicate the different hospitalization episodes. All right. So, and for the patients who are diagnosed of cancer, we're going to have a date. Otherwise, it is going to be missing. All right. So now we finished this part. We have the hospitalizations with the indicator of whether or not the patient has been diagnosed of cancer. So I have a question here, and this one really you have to be careful. Well, imagine that there are two hospitalization records. One is in 2007. The patient was diagnosed of cancer. And then 10 years later, there is another hospitalization, and this time the cancer diagnosis is 0. So, is that realistic? Um, well, it is possible, like because of the reality. For example, there are a lot of people who was diagnosed of breast cancer and then later was cured. So I think there is a rule that for some of the for most of the cancer, it's going to say that if after 5 years the patient is still survive and there is no sign of the progressing of the original lesion, then the patient is treated as is considered as cured. So even if later there is another cancer incidence, it will be considered another cancer incidence. All right, so that is possible even for cancer, right? So that's why in this case, so I just stop here. But imagine that there is another situation. So this time, let's say that it is still two hospitalizations, one in 2007, the other in 2007. The other is 10 years later. It's just that this time it is not about cancer, but about hypertension. And again, in this hospitalization, it has a diagnosis of hypertension, but the other, it does not. Well, so of course, it's unlikely to happen because in the hospitalizations, it will always have that diagnosis because the patient will have that condition. But it could happen, right? Because sometimes for the second hospitalization, and maybe it is the main purpose of treatment is for fracture for others, and it's just that for some reason that diagnosis has been missed. But in that case, can we say that for the second hospitalization, the patient does not have hypertension? I would say unlikely because hypertension is going to be a lifetime chronic disease and it's unlikely. So, despite a lot of people are going to claim that using um, some miraculous treatments, they're going to be cured, but it's very much unlikely, right? So in that case, we might have to think about another data step to treat the data to say that once there was an was once a diagnosis of hypertension, then for the rest of the hospitalization records, even if there is no such diagnosis, we're still going to treat that the patient is having hypertension there. Just So this one is just for to uh, for you when doing your research projects, you have to pay attention to this. So whether or not the condition is is going to be a lifetime on disease um, condition, or it is going to have an on and off period. So in this case, cancer, I would treat it as an on and off period because it sounds like it's more likely to be close to the reality. Okay, that is for this part. So for this part, we've for each of the hospitalization period, we've have first we have a non-overlapping hospitalization periods, and we indicate whether in this hospitalization the patient was having a